We are looking at factoring when we don't have a leading coefficient of just 1. So when our leading coefficient isn't 1, it does complicate things a little bit. So I have a ton of steps written down here, and I do think it's important that you guys take a little bit of time to write all of this down. So like I said, the first thing you want to do anytime you factor is to check to see if you can factor out a greatest common factor. Next, you have to choose between the three methods. The method that I'm going to teach is going to be the AC method. That is by far the most common method you are going to see, and the method that your future teachers will most likely use as well. Okay, so using the AC method, we are going to take A times C, same thing we did. So our A times C value has to add up to our B value. Once you do that, we are going to separate our polynomial, or our B value, into two terms, and then we are going to factor by grouping. The other method that I'm going to show you is the Holland method, and we'll do that with our second example. I'll explain that once I get to it. All right. So the first example here is factoring when A times C is positive. When A times C is negative, it's really the same difference. So let's first of all use the AC method. So for the AC method, once again, remember, our A value is our leading coefficient. So in this case, it is 5. Our B value is our coefficient on just our first degree variable, which is 11. And our C value is our constant, which in this case is 2. So if I was to take A times C, I would get 5 times 2, which is 10. And my B value is 11. So I'm looking for two factors that would multiply to 10, and would add to 11. Okay, if you're struggling to see these factors, you could always write it out. So I've got 10, should be 1 and 10, 2 and 5. So 2 plus 5, definitely not 11. 1 plus 10 is 11. So that gives me my two factors, 1 and 10. So what I'm going to do with these two factors is I'm going to split my B value, which is my 11x, into 1x and 10x. So how I'm going to write this is I'll write this as 5x squared plus 10x plus 1x, or you could just write x, plus 2 equals 0. So as you can see, I just split my B value into two different parts. So now what I want to do is I'm going to factor by grouping. So I'm going to look at my first two terms and my last two terms, and I'm going to see if I can factor out a greatest common factor. So within my first group here, my greatest common factor is going to be 5 for my coefficients and x for my variables. In my second group here, I don't really see a greatest common factor. So our greatest common factor is just going to be 1. I'll actually write that down. So 5x out of the first group and 1 out of my second group. So let's write out our GCFs. So if I factor out a 5x, right here, I have 5x squared divided by 5x, which is just going to leave me with x. 10x divided by 5x is going to leave me with 2. Then over here, I'm factoring out a 1. So I have plus 1 times 1x divided by 1. It's obviously just going to be x. 2 divided by 1 is obviously just 2. And that all is set equal to 0. All right. Okay. So at this point, let's see. So at this point, you are going to combine your greatest common factors. So we'll take both 5x and 1 and make it a factor. And then we're just going to combine our factors inside our parentheses as 1. So I've got 5x plus 1 times x plus 2. All right, so x plus 2 combines as just x plus 2, the same way that adding like terms works, where x plus 2 is just our variable that create our like terms. Okay, so our final factor here is 5x plus 1 times x plus 2. All right. So the next method that I'm going to teach you guys is the whole-in method. So for the whole-in method, you're still going to take a times c. Okay, a times 3, c. So we've got 3 times negative 15, which is just negative 45. And what we're going to do with that AC value is we are going to sub it in for our C value, and we are going to drop our leading coefficient of 3. So how that's going to look is we'll have x squared plus 4x minus 45. Okay, so we subbed our AC in for C and dropped our leading coefficient. Once you're here, we're going to do the same AC method. So we're looking for two values that multiply to negative 45 and add to 4. So that process still stays true, even for this method. Okay, so if we're unsure, let's write out our factors. So I've got negative 45, which would be 1 and 45, 5 and 9. Sorry, I should do 3 and 15, and then 5 and 9. And then I think that's all. 3, 15, 5, and 9. But since our original value is negative, we know that one of these has to be negative. But since my b value is positive, I know that most likely it's going to be one of my smaller numbers that are negative. Okay, so from here, let's test these. Negative 1 plus 45, obviously not 4. Negative 3 plus 15, obviously not 4. Negative 5 plus 9, well, that's 4. So those are going to be my factors. Okay, so at this point, this is where we are going to go through and we are going to rewrite our b value as negative 5 and 9. Well, actually, yeah. So we don't actually even have to rewrite our b value since now we have a coefficient of 1. So now instead we're going to write our two factors as x minus 5 and x plus 9. So it saves us from the entire grouping process. But the one thing with the whole-in method now is that now we have to take our leading coefficient into play. So what we're going to do with our leading coefficient is we're going to divide it by both of our factors. So how that looks is we'll have x minus 5 divided by 3 times x plus 9 divided by 3. So once you divide both your factors by your leading coefficient, you want to see if you can simplify the fractions. 5/3, nothing we can do there. But 9/3 could simplify down to 3. So I'll rewrite this as x minus 5/3 times x plus 3. Okay, x plus 3, that's simplified all the way, but I still have a fraction in my first factor. So what you're going to do with the fraction is you're going to take your denominator and move it in front of your variable. So I'll rewrite this as 3x minus 5 times x plus 3. And that right there is my final answer. So if we wanted to write it out, 3x minus 5, x plus 3. All right, and that is the Holland's method. So you guys have two options now. You know both the grouping, AC grouping method, and you know the Holland's method. To me, it doesn't matter which one you choose. They're both equally as effective. They both work every time. It is completely up to you. So there is 4 more examples on the back page. What I'm going to do with those examples is I would highly recommend that you guys try at least 2 of them and try both of the methods to see if either one works better for you. Then in class, we're going to go through multiple examples, probably 2 of each method, and we'll just keep practicing. All right. Thank you guys for watching. Please try those on your own and come to class with questions.